All right, welcome to our lesson on sine law. So not all the time are we going to have nice, neat triangles that are right angle triangles. Sometimes we're going to have ones that are acute, meaning that they don't have a right angle. So when we don't have a right angle, we can't use SOHCAHTOA. We can't use those primary trigonometry ratios. But what we can use when we have non-right angled triangles are sine law and cosine law. This lesson is going to focus on the first of these. So we're going to focus on sine law. When we're looking at a triangle and we have these large A's, large capital letters, and then these small letters, they refer to different things. The capital letters represent the angles, and the lowercase represents the sides. So, and those are the sides that are directly opposite. So looking at large A, across from it, we're going to get tiny a, which is the side that's represented to it. Sine law works with acute triangles, and it can be written two ways. The first way is sine angle A divided by length A equals sine angle B divided by length B sine angle C divided by side C. And then you just flip it and the same thing. So both of these work, and we can use these when we have either two sides and an angle or two angles and a side. So things to know. Only two of the ratios will be needed to be used with any given time to solve an unknown. Sine law can be used to find an unknown side if you have two angles and a side are known. So S angle, side angle, or side angle, angle. Or if you have an unknown angle, if two sides and the opposite angle of the known sides are known. So those are a bunch of words. Let's try putting this in practice. So if we're looking at this guy right now, we have two known angles, and across from one of the angles, we have a known side. What we're trying to find is the side across from angle A. So this is little a, and we know little c. So what we're going to start by doing is writing out our sine law. I'm going to put the lengths on top, so the sides on top, just to make the movement of our information to isolate for little a lot easier. So you have little a over sine angle A equals little c over sine angle C. Next up, what we're going to do is input all of our information. So A, we still don't know. That stays there. And we get sine bracket 62 equals 7 over sine 58. Next up, what we're going to do is isolate A. So we're going to take 62, sine 62 and multiply it by the 7. So we get A equals sine 62 multiplied by 7 all over sine 58. And we just put that into our calculator, and it's going to give us A equaling 7.28 centimeters. And the question is asking us to find it to the nearest unit, so it's going to be 7 centimeters. So that's the first one. That is our first example. Let's look at another one. So in this case, we have an angle and two sides. We want to find out y, angle y. So what we can do is start off by saying which angles are what to which side. So across from 65, we have side tiny x, and across from angle y, we have side y. Again, let's set this up. I'm going this time put the signs on top, just again to make our solving a lot easier. So we get sine y over little y equals sine angle x over side x. So what we're going to start off by doing is filling in what we know. So sine y, we don't know what that is over 13 equals sine 65 over 17. We're once again going to rearrange to isolate for sine y. So you get sine y equals 13 times by sine 65 all over 17. So we want to know what our y is. So when we're trying to find what our angle is, we use the inverse function of sine. So y is going to equal sine inverse, and this entire statement is going to be in the bracket. So we get bracket 13 times by sine 65 all over 17. You input that into your calculator. Make sure that you have all the brackets in the right spot. Remember, your calculator only does what you instruct it to do. What we end up getting is y equals 43.87 degrees. Again, we always want to make sure our degrees are rounded to the nearest whole number. So y actually equals 44 degrees. All right. Next one doesn't give us a triangle, so we're going to have to draw it out. So I'm going to start off by just drawing out an acute triangle that doesn't have 90 degrees angle. Well, hopefully let's draw that a bit better this time. And this is why we have an app that draws it for us. So the question is saying in a triangle ABC, I'm going to label it right now, A, B, C. Given that B is 48 and C is 25, side A equals 36. Okay, so let's put in what we know. So side A is 36. Side angle B is 48. Angle C is 25. We right now don't know what little b is, and we don't know what little c is. We can find out what angle A is, and how we can find out angle A is remembering that a triangle's interior angles add up to 180. So what we can do is 180 minus 25 minus 48 will give us our angle for A, and that gives us 107. So now we know that this guy here is 107. Now that we have a known angle and with across from it a known side, we can solve for B and C. So I'm going to start off with solving for C, and once again I'm going to put our sides on top to make our solving easier. So we have C over sine C equals A over sine A, where we fill in what we know. We don't know what C is, but we do know that sine 25. And 36 over sine 107. We're going to rearrange to isolate for C. So C is going to equal sine 25 times by 36 all over sine 107. When we put that in our calculator, we're going to get 15.9 centimeters. Okay, so we found C. Now we need to go and find B. So B over sine B equals A over sine A. We fill in what we know. I'm just going to move this up so we have enough space. So we don't know what B is, but we do know that B is sine 48. We know A is 36, and sine A is 107. We rearrange to isolate for B. So get sine 48 times by 36 all over sine 107. And that gives us a B of 28 centimeters. And we can just put a little box enclosing all of our answers so they're easy to see. And that's how you solve a triangle using sine. When we're using Sine Law, we just need to make sure that we have enough angles and sides in order to figure it out. If we don't, that's when we're going to use cosine law, and we're going to delve into that next lesson. We have one more example. Let's try that out. Once again, it doesn't give us a triangle, so let's start off by drawing a triangle. Yeah, that didn't turn out too well. Let me retry that. There we go. That's better. So this time we have a triangle that is x, y, and z. So let's label it x, y. And we're going to bring that down just so I can write on the top of it. And z. Okay. So angle z is 75. We have a y length of 8.2 centimeters. We have a z length of 10.1 centimeters. What we need to find is the x side, which is right there. So we need to find what little x is. I'm going to put those in blue so we can see what we're looking for. Little x. We're having some tablet issues. There we go. We need to find out what y is and what x is for our length. So let's start off by going and finding, let's go find the angle y. We have the length for that, which is what we need. We can't go solve for x yet because we don't have the angle and we also don't have a side length. So we have to wait until we find the angle for x, but we can find the angle for y because we have a side and an angle and we have a side here. So that's what we're going to start off by doing. So we got sine y over little y equals sine z over little z. We fill in what we know. Sine y over 8.2 equals sine of 75 over 10.1. We rearrange to isolate for sine y. So 8.2 times by sine 75 over 10.1. Again, since we're finding the angle, we need to use the inverse of sine. So sine, there we go. My apologies on that. Y equals sine to -1, sine inverse, 8.2 multiplied by sine 75 all over 10.1. We put that in our calculator and we're going to get a y value of 52. So now we know that y is 52. What we're going to do at this point is now solve what angle x is. We're going to use the rule that all interior angles of a triangle add up to 180. So angle x equals 180 minus angle y minus angle z. So give us 180 minus 52 minus 75. That's going to give us an angle of 53 for x. So now we know that. Once we know the angle, we can now use our equation for sine law in order to find out what our last side is. I'm going to use x and z for this one. I'm going to switch to green. So x over sine x equals z over sine z. We put in what we know. We don't know what x is, but we do know it's sine 53 on the bottom. We know that it's 10.1 sine 75. We rearrange I'm just going to move this over slightly so we have enough space. We're going to rearrange to isolate for x. So we have x equals sine 53 times by 10.1 all over sine 75. And that gives us x equaling 8.4. I believe it's centimeters was our, yes, centimeters. And that's how you can solve using the sine law. And that's all for sine law. Go ahead, do some practice, and continue to work on these.